Okay, so today I'll be evaluating polynomial functions and identifying their general shape. It's not too bad what we're starting today, it's the building blocks. So I need you guys to pay attention as much as possible. Okay, Russell? Okay, thank you. All right, pencils down. Let me do this one for you. Okay, so it says, this is kind of like what you guys did yesterday to kind of set you up, but it's a little more complicated now. Instead of just putting a constant in, Russell, like 2, we're going to put an a cubed in. So it's going to look a little bit different. So it's p of x equals 2x cubed plus 6x minus 12. And then we have another function, right? Here's the p function and here's the q function. So for 3a, we're talking about a p function. So I would use this one right here. Only every time I see an x, I've got to substitute it for a cubed. Does that make sense? Okay, so that's what I'm going to do. First, I'm going to kind of draw my shell. So it's going to be 2x cubed plus 6x minus 12. So right here goes an a cubed, and here goes an a cubed. So to further simplify, that would be just a cubed 3 times is a to the 9th. Good. Plus 6a cubed minus 12. All right, this one's a little bit, not too bad, right? That's the answer. That's completely simplified. There's nothing you can do from there. All right, this one's a little bit different. This one says I'm going to have a q function, but when I have my q function, I'm going to substitute 2a. So let me change my color here. Let's go to blue. So I'm talking about this function here, but every time I see an x, I'm going to substitute it for 2a. And then when I'm all done with that, I'm going to multiply the whole thing by 5. Does that make sense? So you work from the inside out. Just like with doing anything with PEMDAS, right? You work from the inside out when you've got parentheses. All right, so with this one, I'm going to draw my shell first. So I have 5 times a huge quantity. The quantity inside of there is going to be 5x squared plus 4. What goes in for x squared? 2a. I'm going to put a 2a in here. Continue. I don't really want to deal with the 5 yet. I just want to evaluate what's inside of here. So 2a, the whole quantity squared, means 5 times 4a squared. So I'm just distributing the square to everybody in there. Plus 4. Let me move this guy down. All right, so now I have 5 times the quantity. So 5 times 4a squared is 20a squared plus 4. Now I've done everything I can inside these brackets, correct? So finally, I just need to distribute that 5. So that would be 100a squared plus 20. Do you guys want to take a moment to copy this down before I go on? All right, let's do that. 1. Okay, so let's try this one that's a little bit more complicated. Jose is going to help me out. Why? Have faith in yourself.
Change the mindset.
Change your mindset. Okay. Yes. You need these 2? I need them anyways, you're right. Okay, so I'm going to bring these down. All right. So here they are. All right, so it says three of these So that's the green one, right, Jose? 3 of these, but instead of x, we're going to use a, minus the q function. All right, so I'm going to ignore this for now, and I'm just going to write 3 and then the p function, and then I'm going to say subtracted by the q function. So I'm going to say 3 parenthesis, or I'm sorry, bracket, p, which is what? 2, parenthesis, where I see an x, right, cubed, plus 6, where I see x, I put a parenthesis, minus 12, and all of that's going to be subtracted by the q function, which is over here, 5 times the quantity of x. I'm going to make it a little bit bigger, though, because it's got something bigger to put in there, squared, plus 4. Everybody with me so far? Okay, so what goes in here? A, or the green part, right? And what goes in here? The blue part. All right, so an A goes in here, and an A goes in here. See how I'm substituting A instead of X? And in this one, instead of X, it's going to be A plus 1. But this one's going to be a little bit more hairy, right? All right. Hairy. I don't know. All right, so this is 2A cubed plus 6A minus 12 minus 5. This is a big thing right here. This is the sum of 2 squares, right? So it's A plus 1 times A plus 1, right? Plus 4 will go nice and slow. Isn't that what that says? A plus 1 squared? All right, continuing on, let's go ahead and distribute. There's nothing else I can do in here. I cannot collect any like terms, so I might as well just distribute that free. So this is 6A cubed plus 18A minus 36 minus 5. We've got to figure out what all this is. You FOIL, exactly. So it would be A times A. I'm going to do a little area model over here for a little visual. All right, multiplication table. A times A is A squared, an A, and a 1. So that would be A squared plus 2A plus 1 plus 4 equals 6A cubed plus 18A minus, this is as hard as it gets today, minus 5A squared minus 10A minus 5 plus 4. Now we've got a bunch of stuff that we can combine, right? All right, so let's go collect like terms. So here's the 6A cubed. Do I have any more? I don't, so let's just write 6A cubed. We don't need to collect anybody. 6A cubed. I like to cross them off when I'm done with them. Now what should I go hunting for? Squares. So here's a square. Is that it? Yep, so I don't need that anymore, so all I have is negative 5A squared. That guy's done. Now I'm looking for A's. So here's 18A and negative 10A. What does that make? 8A. So get rid of those and say I'm done with that, and it's 8A. And finally, I've got negative 36. How about negative 5 and positive 4 is negative 1? Yeah, and negative 1 and negative 36 is negative 37. So that's accounted for, that's accounted for, and that's accounted for. And this is completely simplified right here. So an ugly problem, but is it really, I mean, when it comes to difficulty level, is it really that hard? It's just a process. All right, make sure you've got that down. 1. Okay, why don't you guys try these on your own? Try a 4A. 1. Okay, so I have to write this out. So 2 parentheses squared plus 3 parentheses minus 1. See, Jose, how I wrote this out and put holes where the x's are? And now I just have to go back and fill those holes with what we're putting in our function. So it's going to be b squared and b squared, which equals 2b to the 4th plus 3b squared minus 1. Question? All right, try this one, 4b. I'm going to help you guys and start this one off. This says 2 g's. So 2 g's plus 3 g's. Well, what's the function of g? X squared minus 4. Correct? Isn't that what that says? X squared minus 4. So over here, what's x?
Oh, I did not do that.
In the first one, what's x?
X squared. You said don't worry about it.
You write it out, and then you go back and fill it in, so you don't get yourself confused. All right, do you guys see that? How I ignored it until I just said 2 of the g functions. So I wrote out a g function. This is the g function. 2 g functions plus 3 g functions. Well, this first g function says it only functions when I know that I have c plus 2. Right? And this one only functions when I have 2c. I feel necessary to use apples and bananas. Right? Do you see what I'm saying? You got 2 functions. 2 times this function and 3 times this function. So all you do is take and put it inside of the function. All right, get rid of my apples and bananas. All right, and so I'm going to put c plus 2 in here. I'm going to put 2c in here. All right, so c plus 2 is c plus 2 times c plus 2. Minus 4 plus 3. 2c squared is 4c squared minus 4. Continue on, and I get 2 times, I'm going to do this out here, c and 2 and c and 2 is a 2 by 2. Foil it. So that's c squared and 2c and 2c and 4, which makes a total of 4c plus 4. That's this part right here. This is foiled. I should change the color. There we go. So it doesn't confuse you with the other green. So that became this, minus 4, plus, there's nothing else to do in here, so I might as well just start distributing, right? 12c squared minus 12. Here's a 0 pair, so I can get rid of that. And now there's nothing else to do in here, so I'm going to go ahead and distribute 2c squared plus 8c plus 12c squared minus 12. Okay? So now I'm going to go collect like terms. How many c squareds do I have? 14 c squared. There's 2 and there's 12 makes 14. How many c's do I have? 8c. That's done. And negative 12. And we're done. Questions? All right, let's move on. All right, end behavior of polynomial functions. Okay, so just take a look back to behavior of graphs. Guys, I need you up here. Up here, please. We're shifting gears. Okay, so you should all know what this is. What is this? A parabola or a quadratic function, right? What's the degree of this quadratic function? Degree of 2. It's right here. Degree of 2. What's my leading coefficient? 1. Let's talk end behavior. Okay, so this is your y, f of x, right? And this is your x. Now notice how I've got this. I've got, this is my first quadrant. This is my second quadrant. Okay? So in my first quadrant, as x is going out here into infinity, what is y doing? We should say the same thing, right? So as x is positive going out into infinity, y is also positive going out into infinity, right? It's going up and over, up and over, up and over, up and over, into infinity, right? As x goes positive, y is going positive. So I would actually say, as x is going out into infinity in the positive direction, so is y. Let's talk about when x is going in the negative direction towards infinity. When x is going in the negative direction, what is y doing? It's going in the positive direction, right? So as we're going out here in the negative direction for x, y is going in the positive direction. Okay? All right, my domain. My domain is I'm going to do a foldable for this on Thursday for you guys because I have a really, really good visual for this. All right, so my domain is all my x values. So as you're going out on the x in this direction, isn't it going to infinity? Does it ever stop? That arrow tells me it keeps going, right? And as I'm going in the negative direction, isn't it the same thing? It just keeps going and going? So the domain is all real numbers. But the range isn't. The range, as y is going up, it's going to infinity. But as y is going down, is there any values down here? No. So the range would be y such that y has to be greater than or equal to 0. All right. That's that one done. All right, here's I'm introducing you to a new polynomial function. This is x cubed, which kind of makes sense because x cubed, if I were to take this and, will it let me do it? It's not going to let me because it won't let me flip it. X cubed is really just x squared, only when I put something, a negative in for x squared, it's always going to be positive, right? But when I cube it, aren't I going to get negative values now? So this little curve that goes up, there's always going to be positive, positive. No matter if you've got a positive x or negative x, y is always going to be positive. Well, for this one, what happens when you cube it is this little parabola that comes back up on the negative side goes down. So it looks just like a parabola, only it took a turn in the negative direction. You see what I'm saying? All right, so this is the parent graph of x cubed. So what's the degree of x cubed? 3. What's the leading coefficient? 1. Let's look at the end behavior. You see I have this here, and now it's down here in the third quadrant? You guys see that? So as x is going in the positive direction, what's y doing? It's going positive, right? As we go in the positive on x, what's y doing? It's going up. Up is positive, right? Only down here, when x is going negative, now what's y doing? It's going negative. You're starting to catch on a little bit? So as we go in the positive direction, infinity, y is going positive. As we go in the negative direction on the x-axis, y is going negative. Let's look at this one. I'll do domain and range in a second. Let's look at this one. As x is going in the positive, what's y doing? Is it going up or is it going down? Over here. It's going down. As x is going in the negative direction, what's y doing? Going down. Just say, I'm going on the positive x. Is the graph up or down? It's down. As I'm going negative, what's the graph doing? Going down. Over here, as we go in the positive direction for x, what's the graph doing? It's going down. As we go in the negative direction for x, what's the graph doing? It's going up. Are you starting to catch on? Okay. All right, what's the degree of this one? 2. What's the leading coefficient? -1. Degree on this one? What's the coefficient? -1. What's the domain on this one? All reals. What's the range? Do you see any restrictions? All reals. What's the domain on this one? All reals. What's the range? Less than or equal to 0. Good. What's the domain on this one? All real. What's the range? You just have to ask yourself, are there any restrictions? If there's not, restrictions, like see how there is absolutely nothing up here and there never will be? That's a restriction. We have to say y can't be anything above 0. You see what I mean? And over here, y can't be anything below 0. But I don't see any restrictions for, there's usually not as many restrictions for x. A restriction on x would be a graph like this. Now the restriction would be, y would be all real, and x would be everything greater than 0. You see what I mean? All right, so we're done with that. You can go ahead and sketch something if you'd like to, or you can just copy mine down or print it out. 3, 2, 1. All right, so let's play with this. Describe the end behavior and tell me if it's odd or an even degree. Okay. All right. This, it has one turning point, and this is x squared, correct? The graph turns once. Notice how they're both going up. Negative x squared, they're both going down. Do you notice that this one of them's going up and one of them's going down, that's x cubed? And this one of them's going up and one's going down, and that's negative x cubed. So x to the 4th would be one term. Look, see how this is one term? And this is 2 turns, right? We go this way, and then we go this way. So this one goes 1 turn, 2 turns, 3 turns. So this would be x to the 4th, which would make sense because when it's even, they're both going in the same direction. Do you see that? So this would be negative x to the 4th. So my let's describe our end behavior. That's the first thing we have to do. As x is going positive, what's y doing? As x is going positive, what's the graph doing? It's going down. So this would be negative infinity. And as x is going in the negative direction, what's the graph doing? It's going down. So we want to know if it was odd or even. It's got to be an even because they're both going in the same direction. So it's even. So for the second part of this, it's even. I should have just grabbed all this. This is really sloppy on here. So number 2, it's even. And number 3, see the number of zeros. This has two zeros. Okay, so there are 2 zeros. It's passing the x-axis 2 times, right?
Yeah.
All right, let's talk about this one. Let's talk about what the graph is doing. As we go in that positive direction on x, what is the graph doing? It's going down. And as x is going in the negative direction, what is the graph doing? It's going up. Do you see why I didn't want you to miss this? All right. Number 2, is this one odd or even? Odd, because it's going like this, right? Odd is either like this or like this. So this is odd. And how many zeros do I have?
3.
1, 2, 3. Can you do this on your own now?
Yeah.
Try these on your own. No. Okay, so end behavior. As x is going positive, what's the graph doing? Positive. As x is going negative, what's the graph doing? Negative. Is it odd or even? Odd. How many zeros? 1. Good. Is this odd or even? Even. What's the graph doing when you're going positive? Up. What's it going when you're going negative? Up. How many zeros? None. You guys got this. The number of solutions to a polynomial function depends on what? The number of solutions depends on what?
How it's going.
No.
Wait, the number.
What are the number of solutions for this one?
0, 1.
1. What are the number of solutions for this one?
Root.
When it crosses, yeah, the roots, when it crosses the x-axis. Yes. Even means it's pointing in the same direction. Odd is when it's doing this.
Oh, okay.
Okay? Good job, guys.